the time for the quiz. I shall assign the quiz to you. Just remember, today there are not only MCQs. So along with MCQs, you have to answer a short question. You can write it down on your copy and then take a photo and upload it. Okay. So please do it accordingly. I'm assigning the short question to you. I am assigning the quiz to you, and your time limit is 10 minutes. Try to complete it. Try to finish it by then, and then we shall start our class. Okay. So let me start the quiz. Can you see it? Did you get it? The quiz? The Google Classroom. Okay. Then please start the quiz and finish it on time. But anyway, I have given some buffer time to you to upload that question. But let me start today's class. Okay. So please note that whoever are going to submit after that time should be penalized. Okay. Because from the previous class, I have received a few issues asking that why the marks are not given and all those things. Please remember, once I release the answer, whoever is going to submit the answer after my release of answers are going to be awarded as 0. Okay. So try to submit before I release my answers. Okay. This is the first thing. And the second thing is that today I'm going to introduce you to the TAs of this class. Okay. So there are Samyak. Samyak, are you here?
Yes, ma'am, I am here.
Okay. So Samyak is there. Samyak is a TA. Then Arpit is here. Arpit, are you here? Okay. And then Tejas is also another TA. Tejas, are you here? And there is Shivika. So Samyak here will be here throughout the class, and yeah, Jimmy, it is showing 825 including the buffer time. It is not that 825 is the time that is given to you. I have already told that the given time is 10 minutes, and I have given you some buffer time because you have to upload that part also. But whoever are going to upload it submit it after that should be penalized. Okay. So Samyak will be here, and he will answer your doubts and queries during the class. Okay, because you are facing several doubts during the class also, and since I used to take the class, I am not always able to address all the queries at a time. Okay. Therefore, Samyak will help me in this regard and type your doubts on the chat board, and Samyak will try to address those issues, and I shall address all the doubts whichever will not be clear till then after 35 minutes of my class. Okay. So let's start today's class. Let me share my screen. Are you able to see it? Okay. Okay, Pramod. Actually, I don't like that you submit or you keep some questions unattended because there is no negative marking here. So I want all of you to at least attempt every question. That might be wrong, but you have to attempt every question. I have not assigned any negative marking against any question. Okay. Now, let me start it. Now, the fact is that if you remember, till our last lecture, what we have shown you, I have shown you that how can the bias be induced while we are going to make our decision. Okay. Or how overestimation or since I have already shown you the fact that how inducing some error with some mediation, and since the highest utility estimate is being considered, then for due to some overly optimistic estimate, the things get biased towards the things get biased, and the error keeps on increasing. Okay. Now, this phenomena is known as optimizer's curves. Okay. Optimizer's curves. So, what is that optimizer's curves is? That is, here I am going to give you an example. That is, that, for example, and since you are always biased to the towards highest utility. Now, for example, nowadays we all of us are worried about the vaccine of coronavirus. Okay. Now many countries are developing it and testing it. Now the fact is that if there is some vaccine that is having 90% accuracy, but is tested only on hundreds people, and out of them 90 gets cured. Okay. Yes, mom. This quiz is having one file to get upload. That's why some buffer time is assigned there. Therefore, please don't ask any question regarding it again. Okay. So the optimizer starts is that, for example, there are 100. The drug gets tested on 100 people, and out of them 90 gets cured. So you can say the drug has the accuracy of 90%. Okay, but it could be much more. But the drug that gets tested upon 10,000 people, making 8,000 out of them get recovered, that might be having less accuracy, that might be having only 80% accuracy, but that is more reliable. Okay, so the drug that is curing 90 people out of 100 and the drug that is curing 8,000 people out of 10,000 is much more reliable than the earlier one, although it is having a less accuracy or less utility level. Therefore, this is the fact actually. Optimizer starts is that you will get biased towards that drug which gets tested on less number of data. Okay, that is the optimizer starts. How can we say about reliability? Well, I am going to address your queries a bit later. Just let me explain the things first. Okay, so this is called optimizer sparse. Now, we are going to discuss about human judgment systems and irrationality in them. Okay, so this is what we are going to discuss now. Now, the fact is that that human judgment system actually does not always work the way we are thinking. Means, when human judgment system has lots of irrationality in it. Now, there comes a theory that is known as normative theory. What normative theory comes up with? Normative theory actually describes that the human judgment system should act rationally, and the agents, how rationally the agents should act in the human judgment system. Okay, and there comes another theory, that is descriptive theory. Descriptive theory deals with how human judgment systems actually acts. So there are two theories. One is normative theory, and the other one is descriptive theory. Okay. So normative theory deals with that the human judgment system should rationally act, how it should rationally act. And descriptive theory deals with how it actually acts. Okay. So now let me give you some examples. Now, say there are two possibilities. One is A is having 80% chance of and B is 100% chance of winning $3,000. That similar example I have already shown you, that which lottery you are going to choose and how you are going to accept or decline the lottery. That example I have already given you. Now here the similar kind of example is given, that given these two options A and B, which one you are going to choose? Which one you are going to choose? Any response? B. B is the general response. Any human being will prefer that chance with certainty. Now, you have another two options given, that is 20% chance of winning $4,000 and D is 25% chance of winning $3,000. So given the options C and D, which one you are going to choose? Now C is also the general answer. So now what you can see that you are choosing, you are preferring B over A and C over D. Okay, this is how you are making your preferences. Now, if you calculate the EVM of both of them, you can conclude that utility of 4,000 should be greater than utility of 3,000 if you are dealing with this choice or this preference. But the same is not valid for this one. Why? When you are choosing B over A, that does never mean that utility of 3,000 should be greater than utility of 4,000. That can never happen. Okay? So, this is actually here in terms of preference or utility, what you are from these two choices, if you choose this, you are going to conclude that utility of 3,000 is greater than utility of 4,000, whereas if you come up with this preference, it becomes utility of 4,000 is greater than utility of 3,000. So these two choices actually are totally inverse in terms of utility. Okay. So this is just an example that human judgment systems are not rational. Okay. But no one can say that this preference is wrong. You have preferred something wrong. No, all the preferences are right. But they are coming with a contradictory inference. Okay. So this is why we can't develop a totally rational human judgment system. Now, there comes why you have chosen A over B, B over A, because you know that the gain in B is certain. That is the phenomena that is known as certainty effect. Certainty effect is that people are strongly attracted to the gains with certainty. If there is certainty, then people will be attracted to that possibility also. or to that choice zone. Okay. So now there comes another another example, that for example there are mixture of balls kept there in a bucket. Now person can go for D over C for considering more certainty, but you are not going. Are you going? Everyone here has responded, has chosen C. Certainty means when there is 100% guarantee. But when the certainty both are uncertain, with 20% and 25% both are uncertain, then you will choose the maximum gain, that is $4,000, to minimize your regret. Okay? 25% is obviously greater, but that is not obvious certain. That is not obviously going to happen. That may happen, may not happen. Then you will go for C. That is, you will go for maximum gain to minimize your regret. You should not think that I should have bid for C, so that after bidding for D, you can think that I should have bid for C, and there was also some chance to gain that 4,000. Okay. So here, when you are going to choose B over A, you will be no regret. But when you are going to choose D over C, there will be regret, because you may also lose that D also. Okay? So this is called the certainty effect. Now there comes another example, that is, for example, some mixture of balls are kept there in a bucket. There are, you know that there could be three different colors of balls there present there. Those are black, then red, and yellow. Now you know you certainly know that red balls are 1/3 of the given, and remaining 2/3 could be mixture of black or yellow, or could be solely black, could be solely yellow. You have no information about that. Okay. Now, if you are again given with these options, that is $100 for red balls, for picking up a red ball, and B is $100 for black ball. Then which one you are going to choose? A over B or B over A? Most of you are responding that you are going to choose A over B. Now, again, you are going with another option, that $100 for red and yellow, for a red and yellow, and for black and yellow. Then which one you are going to choose, A over B or B over A? Now you are going to choose B over A. Phenomena that can be observed from this example is that in first case you are choosing A over B, whereas in the second case you are choosing B over A. Why? Because in your mind you have some known probability value. Okay. For red balls here, when you are bidding for it, there could be black ball because you don't know how many black balls are there. There could be no black ball present there. There could be 1/3 amount of black balls present there. There could be 2/3 amount of black balls present there. Okay. Therefore, you know that there definitely will be 1/3 red balls should be present. Therefore, whenever you are bidding, you will bid for A because red balls, the probability of red balls is known to you. Okay. But same is applicable for here also. You know there could be 2/3 amount of black and yellow could be present there. That is why you are bidding for B. So here the thing is that people should always prefer known probability over unknowns. And that phenomena is called ambiguity aversion. It is called ambiguity aversion that people will definitely prefer the known probabilities over unknown probabilities. Okay. So this is another thing. The other thing is framing effect. Okay. Framing effect, what is that? That you are going to present the same information but in different frames. And you are going to attract people towards it only by framing it. All the advertisements are made like that, with framing differently or with only showing its advantage. For example, there is some health system or there is some treatment where the survival chance is 90%. Now it could be framed in two ways. That you could say that the death chance is 10% or the survival chance is 90%. But obviously, it is obvious that the people will get attracted only towards if you are given with two options. One option says you that here the survival chance is 90% and the other option says you the death chance is 10%. You will obviously opt for the first one because the same information is the same or the performance is the same for both the systems. But the way the information is framed to you is the way that you will get attracted. Okay, to make you the offer getting more attractive. Okay, or the performance getting to make the performance, or it is actually the art of representation, how you are going to represent things. Okay, so this is the thing is framing effect. Then comes anchoring effect. Anchoring effect is, it is nothing but to create higher estimate. And we all of us are facing that anchoring effect, most of us. For example, something you are going to purchase, that is, for example, some clothes, branded clothes, and once some brand name is put or tagged there with the cloth, and you know that generally it will not cost more than 500 rupees. Okay, you know that. But what the brand is doing with you, it is making it the MRP or tag as 2000 and then giving you 50% discount. Okay, so what you are thinking, although you are purchasing it with 1000 rupees, you are thinking that you are gaining something. You have gained. You know that generally the cost of this cloth can't be more than 500 rupees. But once it is tagged as 2000 rupees and you are getting 50% discount over it, you have the estimate, you are actually overestimating the things and you are thinking that you are gaining by purchasing a cloth that costs 2000 rupees. You are purchasing it with 1000 and you are gaining something. Actually, you are losing but you are thinking that you are gaining. That effect is called as anchoring effect. Okay. So now we have so far discussed different types of irrationality. Those are present in human judgment system. Okay. So uh, so we but the fact is that the entire thing, these are part of psychology, these are part of this is actually the human judgment system is a part of psychology, and the entire irrationality is not, people are not able to yet map the entire irrationality, and the research is going on. If any one of you is willing to research on it in the view, or in the from the view of a computer scientist's perspective, you are welcome, because those are open-ended problem, and there are many such problems exist there. The human judgment system or human decision making system is actually an open-ended field of research. Okay, so you are free to explore here the things. So this is what we have briefly. An example of problem, I have already given you several examples. There could be many more. I am not a psychologist, therefore I can't give you many open-ended problems. But whatever I have given you, those are also the examples. Those phenomena are not yet mapped in our decision-making systems. Okay. From computer science perspectives. Okay. From computer science perspectives, the thing is that uh, can you incorporate these things into your decision making systems? Can you incorporate a framing effect? Can you incorporate a certainty effect in your decision making systems? Because those are present there in human decision making, and you want to make your decision making systems to think like human beings. Okay, so you can you incorporate those things into a computer or into a machine so that the machine will be able to mimic your thinking? Can you do it? This is the challenges for the computer scientists, because human beings does not take decision in with prizes or keeping some numbers in mind. Human judgment system is totally it does not depend on any numerical values. We take heuristic decisions, and whenever the machine is going to decide something, it has to be some number associated anywhere, any number, but the things should be numeric to it. So mapping of that heuristics to numerics is a great challenge. Okay, and that's what we are addressing every moment. Okay, we're trying to address, but the best way would be if the machine can also be enabled to think heuristically like human. Okay, then only the entire thought process mimicking would be possible, otherwise not. So now we are coming with multi attribute utility function. Okay, so multi-attribute utility function actually is that whenever some large scale decision making is being made, it actually consumes two vital things. One is money required for it, and human lives. How? Now, let me give you a very real-time example, current issue. You know that COVID is a very challenging issue nowadays. Okay? COVID and lockdown. You know that due to that lockdown, there is huge monetary loss. Our GDP goes down to that place where it never was. Many crores of people has lost their jobs. Due to that lockdown, many human or many people died due to poverty, due to because they can't earn their bread, day-to-day bread and butter. Okay? So that's why lockdown caused a numerous amount of loss to us in terms of both money and human lives. But if it was not here, then what will happen? Then also the same thing will happen, because or the things could be worse, because then also due to treatment, because then crores of people will get affected by COVID, then there would be the cost of their treatment that that could be treated as monetary loss. There could be much more human lives lost. Okay, so in both the decision making, that whether the lockdown should be there or should not be there, both the decision making when it involves a entire country, then both the decision making actually involves money and human lives, and the decision makers or policy makers are trying to optimize the things, how there could be some money to the people, how the loss of human life could be minimized, how could it be done. So could there be some balance or trade-off be made between lockdown and no and opening of everything? Could some trade-off be made? That is what nowadays it is going on, that something is open, something is closed, social distancing should be maintained, masks should be there, and all those things. So safety measures should be there to minimize the risk of human lives, and the things should always be in working condition to minimize economic loss and the loss of human lives due to those economic disturbances. And okay, so this is an example that whenever you are going to take some decision, how money and human lives, some large scale decision making, how money and human lives both are given priority. Okay, now you can see, so the thing is that whenever so far whatever we have discussed, only a single attribute was there, but now you can see there are two attributes, one is money and one is human life. Similarly, whenever some decision makings are being taken, it involves a number of attributes in it. Okay, that's why the decision making systems actually are multi attribute decision making systems. It deals with multiple attributes. Okay, now uh, here the fact is that, say there could be n number of attributes. If X is the set of attributes, you can say X1 to Xn. This could be the set of attributes X1 to Xn is a set of attributes of complete vector assignments, and the higher value of each component is equivalent to higher utility. Okay. The thing that I am already giving you, That is, since you are assigning the higher values to higher utility, therefore, instead of, for example, if your attribute is human lives or loss in human lives, you should not treat it as loss in human lives, otherwise, or you should treat it as survival of human lives. Okay? Because then the greater the value is, value will reflect, the greater the utility is. Okay, otherwise the things will get reversed, because if the loss of human lives are greater, then it should not reflect the greater its utility is. Okay, so the things should be treated in reverse. That is, instead of loss in human lives, you should treat it as survival of human lives. Okay, so that the greater it's, the higher value will reflect get higher utilities. Is this much clear to you? Can't we model utility as ML regression problem? We don't actually have data always. Okay, and we, if you want to, it is not a regression problem actually, you know, because why? Because the utility actually gets changed person to person. That is the first thing. The second thing is that you always don't have an idea that how the preference will change or how the preference will vary. I have already given you an example that how the utility of money gets varied. Although money has a strict utility or strict dominant property, still the utility of money gets varied. It may take a S function shape, or it may take, I have already shown you those cards and all those things. So you, with a strict dominating property, you can't estimate that how the preference will vary. How can you define for the rest of the things where there is no certain preference defined? Okay, so that's why the regression is not much suitable. Now, if this much is clear, then I am proceeding towards the next one. Okay. So then comes the thing that is called dominance. Dominance. Okay. Dominance is, for example, here one example is given there in your book, that is, you are going to select a site to construct a airport. Okay. So when you are looking for a site where the airport could be constructed or could be made, airport construction site, you have certain attributes in your mind. Now, three attributes are given here. First is cost, then noise pollution, and then safety. Okay, so these are the features or attributes that are considered while you have to decide whether to set an airport to a certain site or not. Okay, airport setup problem. Now, the fact is that you have two sites in mind, say S1 and S2. Now, if S1, the cost of S1, and the cost of S1 is lower, the noise pollution here is lower, and S1 has more safety, much safer than S2, then anyhow you are going to select S1 over S2. Okay, so it will have all the dominating properties. Okay, that is, say, it is less costly, it is causing less noise pollution, and it is assuring more safety. So it is superior to S2 in terms of each and every attribute. Then you can definitely select S1 over S2. Okay, so if this is the case, if S1 is higher or S1 is preferable in terms of every attribute than S2, that phenomena is known as strict dominance. Okay, S1 and S2 are the sites. Jadip, have you heard me during the entire class? Because I have well explained what are S1 and S2 and how those are set up. S1 and S2, here I am giving you an example to set up an airport site. So whenever you are going to set up, you are given with two choices of sites. One is S1 and the other one is S2. Okay, so now once you are going to choose which site is going to be chosen, that is given those two choices S1 and S2, this is what I am actually discussing here, that in terms of given those attributes, that is noise pollution, cost, noise pollution, and safety, if S1 is more preferable than S2 given any attributes, then you are definitely going to choose S1 over S2, and this property is called strict dominance. But the fact is that when you are given with n number of different choices, there are multiple choices. That strict dominance can only narrow down the choices. It can't give you or make you left with a single choice. It can never be, because for example, in the given example only, if there are n number of such sites under consideration, some might be more costly but less in terms of noise pollution and more in terms of safety, or some sites might be less costly but the safety could also be less there. Some sites might have less noise pollution, but more the safety is more less, and those could be the things. So, in terms of every attribute, means there is very narrow possibility that you are going to get an ideal site, ideal in terms of everything. Okay, so so that is why the strict, yes, right now what are the attributes that we are dealing with have the same ranking. Okay, have the same attributes are having same rankings or same weightage to us, and with these attributes we are going to decide how we are going to choose or how we are going to set our preference over the given choices. Okay, now there comes so let me show you one. Yes, here you can see that here you are given with four choices, A, B, C, and D. There are two attributes, X1 and X2. Now you can see that A is superior, B is superior to A in terms of both the attributes, that is X1 and X2. Therefore, you can, from this curve, you can conclude that B is strictly dominating to A. Okay. but you can't conclude the same thing for C and D, because you can see that in terms of A, C is superior in with respect to attribute x2, but is inferior with respect to attribute x1. Same is valid for D. D is superior to A in terms of attribute x1, but it is inferior to A in terms of attribute x2. So here, see, if you are given with the choices that which one you are going to choose among A and C, or between A and C or A and D, you may not be able to come up with a certain answer. Okay. So, can we take the area? Which area are you saying? The area concept is not clear to me. X1 into x2. Why? These are having certain quantification already. That's why we are able to map it. Cardinality of it. Nothing is clear to me actually. Between B and D, we can't choose. No. Between B and D, we can't choose. Okay. So, this is the problem actually. So, then comes the uncertainty. That is, A is strictly dominated by B. Here you can see that A, even if A is covering a certain region and B is also covering some certain region, but A is always A is getting always dominated or strictly dominated by B, but not by C, because here you can see that this part of A in terms of attribute x2 is inferior to A, that is this part of C. Okay, so this is actually where the uncertainty arises. Now there comes another thing, that is that is called the stochastic dominance. What that stochastic dominance stands for? That is, here an example is given to you, that is, both B and C can be chosen over A. You can say, but you can't say for these data points. The cursor, my cursor is here in this, for these data points, you can't decide that whether you are going to choose A or whether you are going to choose C. Okay. So, these are the things. Now, here actually we are going to deal with that stochastic dominance and how it actually occurs. Here, if you see that here an example is given for stochastic dominance. It is a generalization. Actually, for example, here the cost of airport is given. For example, the cost of the site S1 varies between 2.8 to 4.8 billion dollars. Okay, so it varies linearly, and the cost is mapped there as negative function. Why? Because the more the cost is, the less the preferences. That's why it is treated as negative. Okay, so uh, here you can see it varies between 2.8 to 4.8, whereas it varies between 3 to 5. Okay, now it varies linearly, and you can say that S1 always dominates its S2, and S1 should be the preferable one. With in terms of stochastic dominance, S1, since S1 is dominating S2, S1 should be more preferable one. Okay. Now, here comes another thing, that is, once the things are certain, you know that the setting of the airport at S1, there is not some, well, cost is negative because the more the cost is, the less the preferences. We need to map it. So with higher utility, that's why it is mapped in a negative part of that line. Okay. Stochastic dominance. Stochastic dominance is when you are not giving with a particular point, rather you are giving with a range. Okay. So then comes that stochastic dominance over the range. It is dominating. S1 is dominating over S2. Okay. Then, then what comes that is, now if the cost becomes exact for S1, that is, you are having more information and you can say that the construction, the creating the construction site or the creating the for setting up the airport, it will cost $3.8 billion if we consider S1. Now you then can't decide because you then come up with a definite solution for S1, but you have a range for S2. Then if you are asked to take any option between S1 and S2, you may probably not be able to decide. Okay. So here you are having more information. You are having more information. That is why you can be definite about the cost of S1. But the more information is raising up more confusion. Okay. Because once you are given with a range, you can easily decide that S1 should be preferable over S2. But when this range becomes a definite number, you fail to take the decision. What does the probability indicate here? Probability is nothing but 1 by the range, 1 by the entire range. Okay. So, since it varies linearly. Okay. So, no, we are not choosing S1 because of probability. We are choosing S1 because of its nature. That is, it has less negative value. Okay. Over any point, any data point, it has less negative value. Is it clear? Now, sorry. Then, then comes the then comes another thing, that is cumulative distribution. What does cumulative distribution means? That is, you are taking the integration. Well, let me show you here this one. That is, cumulative distribution means that if you are taking the integration over this range, that is minus infinity to x, and over a for all x, if this is less than this, then you can say less than equal to this, given a number of choices a1 and a2 for two actions a1 and a2 leads to probability distribution this, and then you can see that a1 stochastically dominates a2 for any monotonic non. That is, here let me show you this example. That is, here you are again considering the cumulative distribution, and once this curve should look like that, and you can see that here also S1 is strictly dominating over S2. Okay. Probability here is nothing but 1 by the range. Okay. Here the range is 2, 1 by 2 is 0.5. That is why it is given 0.5. Is it clear? Okay. Now, here comes, that is, then comes the qualitative probabilistic networks. What is qualitative probabilistic networks? What are qualitative probabilistic networks? Those are those networks that take decision based on stochastic dominance and not with numerical values. The thing is that we are not going to discuss these things here in detail. You want, you can study it, but those are not, we are not going to discuss those here. Okay? But there exists something that is called qualitative probabilistic networks, that those are those networks that takes their decision making with respect to that, the stochastic dominance property and not with numeric values. Then what we are going to discuss, that is preference structure and multi-attribute utility. Okay. So we are going to now discuss about preference structure and multi-attribute utilities. Now, say we have n number of attributes, and each attributes does have the number of dimensions. Now, if you are coming with some worst case, that is, if the agent have no regularity, then you will need d to the power n number of values to design a complete utility function, to come up with a complete utility function. Okay. So if you are having n number of attributes with n attributes with each is of having the dimensions, then you will need d to the power n values to design the utility function in the worst case. Okay. Now, generally, people have relation among the individual. Yes, someone's microphone is off. On. Please mute it. Well, then we preference have no. If the preference have no regularity in it, then then only you will need d to the power n number of values. Hello. I don't know whose microphone is on. Please mute it if possible. Hello. Yes, Mr. Shudipta, if you have anything to ask me, you can write in the chat box, but please mute your microphone. Okay. So, and then comes the representation theorem, that is, given n number of attributes, the utility function with those n number of attributes should be have some relation in between them. That is, you are given with, say, x1 to xn number of utilities, okay, and your number of attributes over which you are going to define your utility, then it should be defined with so one x1 to fn xn, that is the utility with respect to with respect to n number of attributes, and here all the attributes with respect to each individual attribute there should be a value function, and all those value functions should be should be able to be combined with some simple equation, okay, with some simple function. If capital F is expected to be a simple function such as a summation, okay. So this is how the utilities could be, whenever you are given with a number of n of different attributes for every individual attributes. Dimension means number of possible value of attributes. Yes. Now, uh, now there comes here we have generalized the thing. Now we are going to some particular things. We are going to describe the preference without uncertainty. Preference without uncertainty. Now, whenever there is no uncertainty present there in an environment, the environment becomes deterministic. That is the value function. Did you remember the value function we discussed in our last class? What the value function is? Value function is actually the order of preference. Okay. So in a deterministic environment, the order of preference should be defined or value function should be there. Now, there comes some basic regularity. What are the basic is? That is, basic regularities there comes the basic regularity. Basic regularity is preference independence. What is known as preference independence? Preference independence. That is, if you are given with three attributes, say x1, x2, x3. You are given with these three attributes. Now, you can say that x1 and x2 are preferentially independent of the attribute x3 if and only if the if the preference outcome between these two choices does not change. Okay, preferential outcome between these two choices does not change. That is, your preferential outcome between x1, x2 and x1 bar and x2 bar will not change whether you are having some value of x3 or not. Okay, so your preference should remain the constant then only you can say that x1 and x2 are preferentially independent of the attribute x3. Okay, so let me give you another example, otherwise the things will not get clear. Say it is the same problem, that is airport setup problem. You know that there are three attributes. The attributes are noise, cost, depth or safety. Depth. Now, say you are going to set up a site, okay, and you will prefer a path. Whenever you are going to set up that airport site, the flight path where 20,000 people lives should be preferred over the flight path where 70,000 people lives. Okay, so if you are given with two choices, that is 20,000 people live in the path and cost is $4 billion, and B is 70,000 people lives in the path and cost is $3.7 billion. Then A will be preferred over B always, because X bar and Y bar are two different choices. Okay, here you can see that 20,000 you could treat as X1 and 70,000 you can treat as X1 bar. Similarly, 4 billion you can treat as X2 and 3.7 billion you can treat as X2 bar. Okay, so these are the things that are given. You want to ask that what if the cost is $1 billion? Then the choice might get changed. I am not sure going to be the choice, but the choice may get changed obviously. So preference independence is when there is no strict dominance. Dominance is could be with respect to some attributes, and yes, there is no strict dominance means that here actually the attributes are independent with each other. Okay, preference independence and strict dominance are two different things. With respect to each attributes, you might have a same dominance of same choice or same preference. Then only strict dominance comes. But in case of preference independence, it is the independency among the attributes. There are no relation between these. Okay, so the cost, these are the things. Now here actually, since people lives are given much more priority, therefore you are going to choose A over B. But here the safety level of, or the safety level for both the cases is 0.3, say 0.03. Here also the safety level is the same. Safety level remains the same. Okay, so here what you can see that although these are, so the preference between these two won't change depending on the safety level once it remains same. If you change the safety level for both the cases, say you are making it to 0.06 for both the cases, then also these choices between A and B will remain the same. Okay, so you can say that this safety, that is this feature, is preferentially independent with respect to these two features. The same is applicable for the rest. That is, these two features, that is again say similarly cost and depth is preferentially independent of noise, and same is applicable for noise and depth. Those are preferentially independent of cost. Okay, so this for these attributes, this is how the preferential independence works. Okay, now if there is a set of attributes, this is an example of it, where each of the attribute are preferentially independent to the rest, then it calls the set of the attributes is called what? Called mutual preference independence. Mutual preference independence. So this set of attributes can be called as mutual preference independence. Okay. So, well, let's finish up today. Now, let me discuss with you the answer of the quiz or the short question. Remember, after that, no question should be considered, no answer should be considered. Okay. So, okay, rest of the preference could be anything. So, any human, I'm sorry, I got muted, I did not notice it. So, anyway, any living object should prefer life over death. So, this is an example of monotonic preference. So, preference elicitation is required to make the system enable to take the agent's decision. That is why this is the correct option. Micromort, you know, it is the unit quantifies chance of death, chance of one death in a million. Okay. Now here you need to compute it. I think you are able to compute it. That is, the lottery is given up with a coin, and here actually instead of, if you don't play the lottery, your reward will be zero. If you play the lottery, you will either have a reward of plus 1000 or you have a reward of minus 400. So this is how the EVM of the lottery gets computed, and it is 1000 minus 400 divided by 2, that is 300. Okay. Now here comes, well, I am going to discuss it last. And then if the dollar 200 is paid in the lieu of the lottery, then the insurance premium will become, that is 300 minus 200 is equal to $100. So this is what. Now let me discuss how it should be done. This is how the acceptance or decline, with which one you are preferring, accepting or declining? Just write it in the chat board, which one you are preferring, whether you are accepting or declining. Declining. Then what you need to prove is that anyone will prefer declining, because if EU of accept here is equals to, given SK is the amount of SK minus 400 plus SK plus 1000. Okay. So player has to pay 400. So, and EU decline is so. Now you have to prove it that EU accept should be greater than EU decline, and you have to define accordingly the utility values. You can define U of, I am just giving you an example. If you have given some other value and proved it, I am going to give you marks on it. K minus 400, say you are assigning the utility to be, say, 1. Okay. Whereas U of SK, say, have the utility of, say, 6, and U of SK plus 1000 as the utility of, say, 7. Now you can prove that then EU accept becomes, accept is equal to 4 and EU decline becomes 6. So EU decline is greater than EU accept, therefore you are going to decline. Okay. Okay. Mr. Bharat, your question is not clear to me. Decision making already depends upon the reward value. Is if the reward value of, it is not clear to me. You have to prove the thing mathematically, and this is how you are going to do. Okay, this is the answer. Okay, so this is how the answer should be. Here you can prove that, yeah, expected utility of decline is greater than expected utility of X. So you are going to decline. Okay. So So that is all for today's class. Please go through the class and let me know if you are facing any difficulties in following it. Okay. So see you tomorrow again. Have a good day. Bye.